Okay, I just started streaming. I'm hoping people can hear me. Can I get a check on sound? Can everybody hear me? Okay, there's still a minute left. I'm just going to wait till 10 o'clock rolls around perfectly here. Hello, everyone. Okay, 10 o'clock. Time to start. So, as I mentioned in the Google Classroom, today we're going to be doing hopefully a quick lesson on scientific notation to introduce the idea. Hopefully it'll be quick, we'll see. And then we might be starting on word problems dealing with exponentials. We'll see how much time we have. I do want to try one little thing, not halfway, like somewhere soon, beginning of the lesson, with your cell phones, to see if we can get a little bit of interactivity going on. It might completely fail, we'll see, but we'll give that a try soon. So, what is scientific notation? Scientific notation is a way to write really big numbers that have a lot of zeros, or really small numbers that have a lot of leading zeros, so 0.000005, without writing all those zeros out. Sometimes it doesn't actually have to do with the zeros, though. Sometimes it's just a way of writing the number in a standard way, with a set amount of what we call significant figures or significant digits, which comes up in science quite a bit. So just to show you, and I hope this is going to work. So here's a website that I found online that has just a bunch of science constants. Yes, that's right. In chat, you got it. So when you start taking higher level science classes, and you might have actually seen some of these already, this is just some of the constant numbers that you'll see. And what I want you to notice about a lot of them is they've got these weird symbols next to a few digits at the beginning. So you've got times 10 to the negative 27, times 10 to the 23, times 10 to the negative 10. That is what scientific notation is. And I just wanted to reinforce why you're going to need this, not just in this class, but for your future learning as well. Scientific notation is used all over the place in science. And if you look at some of the topics, you might not understand all of them right away. Like Avogadro's number, this is a chemistry idea. This is the amount, and I'm not a chemist, but if I remember correctly, this is the amount of molecules or particles that are found at what we call standard temperature and pressure. And it's just the number mole here. It's kind of like the number, or sorry, not the number, but the unit mole is kind of like the unit for dozen. It just means a certain number of particles. And this is per mole. So Bohr's radius, I believe, has to do with the radius of a hydrogen atom. Gosh, I haven't looked at it in a while. I'm pretty sure that's what it means. But like electron charge to mass, which I find amazing that we actually know these kinds of quantities, but we do. And like at the bottom here, one of my favorites is the speed of light in a vacuum. So 2.99 times 10 to the 8 meters per second. And we're going to discuss what that all means. So Just so I have an idea, can I get just a few people to say whether you have or have not seen scientific notation before? Yeah, and I find that this has been kind of the pattern in the class. Some people have seen it and some people haven't seen it. So I, I kind of going to teach it then. A lot of people are saying yes. So we're going to teach it at a certain speed. If you find it is too fast, please let me know in email somehow that you might need a little bit more help. I do have, if my interactive presentation works properly, I'll get an idea as to how well and how comfortable you all are. But I am going to go through this as a lesson just to refresh your memories if you haven't seen it in a while. And one of the things I had asked you to have nearby is a calculator, and I was kind of hoping you would do 10 to the 100 on a calculator and see what kind of result you get. So I'm going to bring up my calculator here and show you what happens when you do 10 to the power of 100. So I don't know what your calculator is going to do, because there's and I'm going to show a slide with different results on calculators that you can expect when you're dealing with scientific notation. The common practice on calculators is to use the letter E. Now it could be a lowercase e like it is here. Oh, you can't see that calculator. Hold on a second. Okay, sorry about that. I think you can see this one now. So all I did was 10 to the power of 100, and here says error. So that means that the calculator can't do 10 to the power of 100. Now it has to be in scientific mode. So if you didn't have your calculator in scientific mode first, if you're using like your cell phone calculator, that would be the first thing I would do. If it's still getting an error for most people, let's do 10 to the power of 20 maybe. Okay, see, my calculator actually can show all of the digits for 10 to the power of 20, but probably a lot of your calculators can convert it into scientific notation. The point is that at some point your calculator is going to switch over to an E or some sort of symbol to represent scientific notation. Yeah, so 10 to the 100 is too big for some of your calculators. So try 10 to the 20. I wonder if 10 to the 10 might even work. Okay, yeah, 10 to the 10 might even work. My point is, at what point will you start seeing this E show up in your screen? That's what I'm trying to get you to see. So if you can't get it to work, let's look at some examples on Smartboard that I looked up yesterday. Oh, I'll come back to that. Oh, where did that slide go? Okay. Oh, here it is. Sorry, folks. I guess I decided to show this a little later, but I'll show it now because we were just talking about it. So on a calculator, you might see these three different types of scenarios. So I hope you can see my cursor there, but this is a scientific notation number written on a calculator. And just to explain why I'm doing this right now, folks, when we get into exponential calculations, often you will get very, very big numbers or very small numbers. And I've often forgotten to tell students, when you work on your calculator, you might end up seeing E's, and then they start asking me, sir, why am I getting an E on my calculator? So this is the reason why I'm doing this, because you will see answers like this, which just means scientific notation. Some older calculators might show it this way, where you have your decimal number and then an 18 that looks like a power, but it's actually not a power. It means times 10 to the power of 18, which I'll explain in a minute. And then there's this, which I like on newer calculators. It'll actually say times 10. It might still raise the number of the exponent of the 10 up in this like superscript position. Sometimes the times 10 is like at the bottom of the calculator, and you'll have the exponent right next to it. But there are multiple different ways that calculators show scientific notation. So let's get back to this, and I'll get more into that in a minute when we start actually doing the calculations. So what are the basics of scientific notation? Well, why am I talking about times 10? Well, we know that when we multiply by 10, all it does is it moves the decimal place to the right, and any blank spaces are created are filled with zeros. So let me explain what I mean by that. If you have 5, don't want to use red. If you have 5 and you multiply 5 times 10, well, all that happens is the decimal that's here moves to the right by one space, and we replace we put where the empty space that's created is a 0. So this would become 50, and this is not difficult. If I do 5 times 100, well, that means move the decimal place twice, and we replace the two blanks by zeros, which becomes 500. Now, 5 times 100 is just 5 times 10 to the power of 2. So multiplying by 1,000, multiplying by 10,000, etc., we can replace all of those things by just multiplying by 10 to a specific power. And it's pretty easy to convert this to 100. The power of 2 just means there's 2 zeros. So if it was 5 times 10 to the power of 3, that would just mean there's 3 zeros. Okay? Now, if we divide by factors of 10, so I'll use the same example as 5, with 5. Oh, sorry about that. So 5 divided by 10, that just moves the decimal place one spot to the left. It's Monday morning. Okay, which gives 0.5. If I do divided by 100, that moves the decimal place 2 spots, and again we're replacing any blank spaces, like this one right here, with a 0. And we put the decimal where it ends up when we move it to the left. Now the thing is, you can actually write a division by a factor as a multiplication. You know what? I'm going to do this. I think I have room next to it. I hope this can be seen. You can write this as a multiplication by 10, because dividing by 10 means multiplying by 1/10. 1/10 can be written as a 10 if we flip it upside down. And when we flip things upside down in math, that gives a negative exponent. So I can rewrite 5 divided by 10 as 5 times 10 to the negative 1 exponent. The negative 1 exponent means flip this upside down, which actually means divide by 10. So this format and this format for multiplication look exactly the same now. Becomes a standard. For this one, I'm dividing by 100. Dividing by 100 is like multiplying by 1 over 10 squared. 1 over 10 squared is 1 divided by 100, so that's dividing by 100. Well, I can write 1 over 10 to the power of 2 as times 10 to the negative 2. So now we've got a standard way of writing these numbers, whether they're dividing by 100 or whether they're multiplying by 100. You just write a negative exponent when you're dividing and a positive exponent when you're actually multiplying. So we can write any number using this method now and having the same standard way of writing it. And this will make more sense with examples, which are forthcoming. So before I show those examples, you kind of need to know what is the basic structure of a scientific notation number. And the basic structure is always the same. The very first law or rule is you must have a non-zero digit as your first number before the decimal. Okay? So I don't know how to write that out. Non-zero digit and it can only be one digit. So I'm going to actually write that, one non-zero digit before the decimal. So that's one of the standard way, one of the first rules you need to know for this standard way of writing scientific notation. So the first number in both of these cases is non-zero. Okay, so you can't have 0.34. It has to be a number other than 0. Then you're going to have the times 10, which is always there. And you're going to have a power that's going to tell you whether the decimal moves right, if it's positive. And you're going to have a power that's negative when the decimal moves left. So I realized, folks, that I hadn't been posting the notes to the Google Classroom, and I'm sure some of you probably want to have those notes. I did that. I mass posted them all in one post. I will try to keep remembering to post the notes as well, so that for those of you who can't write the notes fast enough, or for those of you who just want to listen, you'll have the notes that you'll be able to print off, okay? And if I ever forget, please remind me. I'm trying to juggle a lot of things right now, and sometimes I'll forget little things like that. So just let me know if I've forgotten to post the note, but I will try to remember to do that from now on. So using these rules, let's look at a few examples. And the examples will hopefully make things a lot simpler for you to understand. And like I said, I had already shown the calculators here. So convert the following numbers into scientific notation. So let's try, I'm just making these up as we go here. I'm going to start with the easiest ones, the ones that do have a lot of zeros. So if I asked you to convert 325,000 into scientific notation. Okay? So here's the thought process of how to do this. And I know some of you are probably going to be able to figure out the answer right away. That's great. But I'm just going to explain the thought process here. So the most important rule is our first number has to be a non-zero digit. Okay? Well, this is the first number in the entire value here. That's going to be our first number. So basically what we want to do, let me just go back for a second. I want to see the colors I used. So I used green to represent that aspect of things. So we want the decimal to be right there. We're forcing the decimal to be right there. The decimal right now is here at the end of the number, but we are going to manually put it right there. Okay? So we'd write 325. And we're going to manually put the decimal right here. Now the point of scientific notation is often to drop all these extra zeros. So all that these zeros are doing is telling us that this number is not just 325, it's 325,000. So they're basically placeholders that show us what the, what do they call that? The position, I'm forgetting the terminology here, that it's a thousands number, okay? So we're going to replace those zeros and the fact that the decimal place is moving by a times 10, which I believe I used red for, so I'm going to use red for that. Okay. Everybody can still hear me? Okay, everything's going well. Okay, perfect. I sometimes get caught up, as you know, in class. I'll get caught up and run away with my lesson. You have to slow me down sometimes, so I'm going to try to remember to do that. And let's just see what color I used. Okay, so I used blue for the exponents. I'm going to use blue for that. So if we manually put the decimal here, how far do we have to move it to get it back to where it's supposed to be? And this is one of the only difficult things about scientific notation is you have to decide or count how many places to get it back to where it's supposed to be. The answer isn't 3.25. The answer is 325,000. I have to make the answer work. So manually putting the decimal here, what do I have to multiply by as a power of 10 to get the decimal back to where it's supposed to be? Well, 1, 2, 3, 4, 5 spaces is how far it's moving. Every time you move to the right, you put a positive exponent and you add up to 5, so the power is 5. And that is your scientific notation answer. On a calculator, you might see 3.25 e to the 0.5. Okay? So the e, which I think is one of the worst choices for a variable ever, because it looks like it means exponent. Okay? And I have had students think that this is 3.25 to the power of 5. So please be very careful. The e does not mean just exponent. The e means times 10 to the power of 5. Okay? So if you ever see an e on your calculator, from now on, that's what it means. Okay? So let's try another example. Let's try an example of a small number this time. So let's try 0.0067. And we want to convert that into scientific notation. So again, the very first thing we want to do, we want to manually take that decimal and place it after the first non-zero digit in the number, which is 6. All right? So we're going to write 67 and place the decimal after the first non-zero digit. Then, following the pattern, we're going to write times 10. And then we're going to figure out how far do I have to move the decimal to bring it back to where it's supposed to be. The decimal is supposed to be here. Well, that's counting 1, 2, 3 to the left. Because I'm moving left, it's a division by 10, which means I need a negative in my exponent here to mean division by 10. Okay? So that's the only difference when you have a small number, like a decimal under 1, compared to a really, really big number, is the signs of your powers. And that's really all there is to scientific notation. Now, in science, you're going to learn about significant digits. Sometimes you won't be just getting rid of zeros. You can write any number in scientific notation. Okay? So imagine for a second if I asked you to write this number with it rounded to 2 digits. I don't want to do a lesson on significant digits. I was considering it, and then when I started reading about it, I'm like, you know what? I'm going to leave that to your science teachers. But this will be a good little preparation for that idea. I could ask you to write an answer from a number that is rounded to a specific number of digits. Now, when I say 2 digits, I don't mean 2 decimals. I mean, I just want 2 numbers representing this answer. How can you write 453.8 rounded up so that only 2 numbers show up in the answer? So I'm not asking for a precision of decimals here. I'm asking for just 2 numbers in the answer. So, well, if I'm looking at just 2 numbers, well, 450 has 3 digits. I'm asking for 2 digits. And this is where, in science, you're going to learn about significant digits. Sometimes your answers can't have more than just 2, no matter how big they are, because so how do I write 45 but as a 450, right? Like, it still has to be 450, right? So let's take it in steps. If we rounded it off to 2 digits, now technically I'm going to round it off to 3. Getting rid of the 3 and the 8, the first thing we would do is round it to 450, okay? But I need only 2 digits. This is where scientific notation is really powerful when we're dealing with significant digits. I can write 450 as 2 digits because the times 10 to the power doesn't count as digits. All it does is move the decimal place for us. So I need it to be 450. Well, how many spots so if I'm placing the decimal here, how many spots over, sorry, that's supposed to be green. How many spots over do I have to move it? Well, I have to move it 1, 2. So this is going to be a power of 2 here. Yes, Monday math. Monday math is always whacked. I agree. Oh, that's hilarious. We all suffer from the same problem. Okay, good morning. Thank you for just arriving. You can arrive whenever. That's not going to be true next week. When we do online learning next week, I'm actually going to have to take attendance at some point. But anyway, so those are your 3 general examples of scientific notation scenarios. Really big numbers with a lot of zeros. Really small numbers with a lot of leading zeros. These are trailing zeros and these are leading zeros. Or being forced to write a number with only a certain number of digits in the final answer. So I hope you understand what I meant by 2 digits now. Okay, and in science you'll learn that this will be said 2 significant digits. So 4.5 would be the 2 digits, but we can still write 450 with 4.5 just by putting in scientific notation. I'm going to reiterate one really important thing about scientific notation, and like I said, it's one of the hardest things to remember. If you have a number like this, okay? And this is one of the biggest mistakes that students make. You are not saying times 10 to the negative number and forcing the decimal or moving the decimal here. Okay? That's not what's happening. You are manually just grabbing the decimal and plopping it after the 5. Okay? That is not a mathematical thing. That is something that you are doing. You need the decimal to be after the 5. You're placing the decimal after the 5. This is the actual number. Wow, that was a terrible highlighting, sorry. That is the actual number, okay? You need to turn this number into that one. So how do I have to move the decimal place over to change this number into that one? Well, I'd have to move it back 4 places to the right. You're physically placing it after the 5, but you have to move it back to where it was originally. And that's where the times 10 comes in. The times 10 moves the decimal back to where it's supposed to be, which is 1, 2, 3, 4 spots to the right. This is where the decimal actually is supposed to be. That's why this is a power of 4, not a power of -4. I know it looks like we moved the decimal to the left, but we placed the decimal there. And I'm trying to use specific language here, okay? So you're grabbing the decimal, popping it out, popping it in, and then saying, where do I have to move it back to where it was originally? Am I moving it left or am I moving it right? So I'm moving it right because the original number was 54,500. So I'm hoping that that'll help a little bit. There will be some practice with scientific notation, which I'll probably correct tomorrow with you. And I'm hoping that fixed whatever issues some of you might have been having. So if not, like I said, you could always ask for some extra help. Either email me and I can, jump on either Google Meet or Zoom with you and help you out a little bit more individually. So I really enjoyed today's lesson. I hope you did as well. Scientific notation is near and dear to my heart because as a past physics teacher and science teacher, we use scientific notation quite a bit, and it is a very important part of math and science as you go on. So here, you can't see me right now. Yeah, so scientific notation. I can't even begin to explain how important it is. For those of you who've seen it before, great. I hope it wasn't too boring, but it's always good to review anyway. And I'm going to put on the Google Classroom a sheet that is going to be practice for this. But I do recommend that you practice this stuff just to make sure you master it. And for some people, mastering might mean doing one question. For some others, it might mean doing all of the questions. Okay, so I really appreciate it if you do practice some of the questions, at least from the handouts that I'm posting to the Google Classroom. Okay, but we're going to end the lesson there. I'm going to wait a couple of seconds to see if there's any questions in chat. So I'm not seeing any questions pop up in chat. So if anybody needs extra help with scientific notation, what I might do as well is I might link some YouTube videos on scientific notation. For those of you who struggled, you might be able to get a little bit more help from another point of view. But I'll post all that stuff on the Google Classroom. You're very welcome, everybody. This is, even though I struggled a little bit with the Pear Deck thing, this is starting to get a little bit easier for me. So I'm feeling less stressed about it, and hopefully that's coming across. So let me know. Email me if you need any extra help. Oh, and I forgot to ask, how did the assignment from last week go? So if there are any questions about the assignment from last week, please also email me about that. Everybody good? So we'll see you tomorrow at 10 o'clock. Enjoy the rest of your day. And like I said, I'll be posting that stuff on the Google Classroom in a couple of minutes. Bye, everyone. Nice to have you in chat today.